Hi there. In this lesson, we are going to talk about the applications of derivatives. In this section, you are going to learn about the slope and the rate of change. You will also learn how the slope and the rate of change are related to each other. So, let's begin. The rate of change is defined as the change in one physical quantity with respect to the change in another physical quantity. In order to understand this definition, we need to write this definition in mathematical form. So we can write rate of change is equal to change in one physical quantity divided by change in another physical quantity. Now let's try to establish the relationship. So let's consider a function y is equal to fx. Let the value of x increases from x to x plus delta x. In the same way, the value of y increases from y to y plus delta y. So when the values of x and y are increasing, the value of the function will be y plus delta y is equal to f of x plus delta x. As we can see, for this function, y and x both are increasing. Now, let's find the change in the value of y. Y plus delta y minus y is equal to f of x plus delta x minus fx. So, this y will be cancelled out and we have delta y is equal to f x plus delta x minus fx. Now let's try to find the rate of change. So the rate of change is equal to delta y over delta x, and as you can see, delta y is f of x plus delta x minus fx. Now let's substitute the value of delta y over here. So if we do that, we have delta y over delta x is equal to f of x plus delta x minus fx over delta x. As you can see, this is the change in y over change in x. So let's try to understand graphically. So this is my right triangle, and delta y, which is the change in y, and delta x, which is the change in x. So basically, the change in y is my rise and the change in x is run. So if you remember the definition of the slope of a line, which is basically rise over run, and that is equal to the slope. So we can definitely say that rate of change is equal to delta y over delta x, which is also equal to the slope. Now let's take the limit on both sides. So what I'm going to do, I'm going to take the limit delta x tends to 0. So my rate r is equal to limit delta x tends to 0, delta y over delta x is equal to limit delta x tends to 0, this term right here. As you know, limit of delta x tends to 0, delta y over delta x is dy over dx. So r is equal to dy over dx is equal to limit delta x tends to 0, f of x plus delta x minus fx over delta x. In other words, we can say that if we want to find the rate of change of any physical quantity with respect to another physical quantity, what we can do, we can differentiate the dependent physical quantity with respect to independent physical quantity. Technically, what we have done so far, we have established the relation between rate of change and slope, and they are also equal to the differentiation of first order.